So like what we have seen earlier, we have learned about the term of leading and lagging, right? So this is in terms of its signal waveform, right? So there's another thing that you can learn about, like you see over here, right? This is actually what we know as the phasor diagram, all right? So please be very clear about it. So if you are getting asked to sketch a waveform, all right, remember sketch waveform, basically sketching out how the waveform looks like, yeah? So for on the other hand, if they ask you for drawing out the phasor diagram, it basically means this one over here. All right, let me give you an example of how this could be. All right, so for example, this V over here, you know that this is actually a sine wave, right? I can just simply use anything. For example, I can just use 3 sine 60t. All right, that's just one example for my voltage. All right, so in this case, always remember, all right, over here you have your current, right? And you know that your current is starting from the left side, all right? This basically means that it actually has a little bit of a delay and stuff like that, all right? So in this case, as what you have seen over here, all right, when you draw a phasor diagram for your VT over here, you know that you do not have any phase difference over here, all right? Because any phase difference and all that, if I write down just the general term, it will just be let's say EM, all right, sine, and then omega t, and then it could be plus or minus your phase degree itself. All right, this phase degree over here is this thing over here. All right, so like for example, like your voltage signal, it's a sine signal, but it doesn't have any phase because it starts right from 0 over here. That's why you can see that it stops at omega t itself, because otherwise it can also be represented as plus 0, but since it's 0, there's no value to it and all that. How are we going to draw this out? This is how we draw it out. All right, for phasor diagram, the y-axis is what we know as the imaginary part, which normally we put it as J. All right, this we put it as R because it's the real value, yeah? So in this case, this will be the phasor diagram of, or what we call as the vector for your VM, all right? There's no any other degree, all right? And basically, this itself, all right, will just be of 3 for the magnitude. From here all the way to here. All right, doesn't matter how long you actually draw it out and all that. The most important thing is that you know where it lies on. All right, that's the most important part. But as you can see, for example, like for this one over here, okay, let's put this as, what do I put it? Let's say I put it as 5. All right, then I put it as sine. All right, and then I put it as I can put 60 degree, 60t, don't worry about it. All right, and then plus, this is just an example, yeah? So let's say this is 30 degree. All right, this is just a representation of my eye. All right, so how am I going to draw this out? All right, in fact, when you draw it out on a sketch diagram over here, you know that this amplitude over here is actually 5. All right, so do remember to state this. All right, sorry, this should be actually should actually be of higher value than this one, but anyway, let's take this as 2 examples in separate, yeah? So let's say this is 5 sine 60t plus 30. Alright, so these are the important things that you have to remember. If it's a plus, alright, it literally means that your waveform, your sine waveform actually starts from the left hand side. Alright, anything that's shifted to the left is denoted by a plus sign. Anything that is shifted to the right basically means that if this is actually starting from this point over here and then it goes by whatever it is, then this itself is represented by a minus. Alright, so just always remember, for a plus, it means that it's shifted to the left hand side. If it's a minus, it's on the right hand side. Alright, just as simple as that. But the most important thing is that I would like to show you, like if you draw your current waveform to be like this and it's being represented as 5 sine 60t plus 30 degree, alright, this is how you draw it out. Alright, for something of positive value, you just draw it right above in reference to your x-axis. Alright, this will be like your IM. In fact, you can actually denote this IM as 5. Alright, because that's what the magnitude of this is. Alright, and this degree, as you all know, you would have guessed it by now, it will be 30 degree. Alright, so it's important for you to label all this when you are drawing your phasor diagram. Alright, remember your y and x axis, which is your j and your real. You can put RE here or you can put R. Most importantly, draw out the vector. This is what we call it. It's basically just like an arrow and a line, right? And always remember to write down the value of it, alright, of the magnitude, and as well as the degree, the phase difference. Yeah, so some of you might ask, what if, let's say I have this waveform over here just now. Alright, maybe I should just put a different color to indicate this. So for this itself, let's say, alright, it starts over here, and let's say I put it as 10. Alright, I put it as 10 sine. I just take 60t because it's just for easy reference, because the most important one is that I want to show this part over here. It can be, let's say, minus 40 degree. Alright, if it's minus 40 degree, alright, so which means this is of 40 degree difference. If I am to draw out the phasor diagram for it, I have a J over here, and then like I said, I have an RE over here. Alright, just to indicate the real part here. How am I going to draw this again? If it's a minus, it literally means that it starts at the bottom of it. Alright, just remember our arrow. Alright, write down your 10 over here. Very important for you to indicate what signal is it. Alright, for example, this is V, this is I. Let's say this signal is S, for example. Alright, so write down S so that we know that which signal you're talking about. And over here, just label, remember to label that this is actually 40 degree. Alright, so these are the common important things that you will need to know. The axis, alright, depending on whether it's negative or positive. If it's negative, then it will start at the bottom of your x-axis. If it's positive, like this one over here, because it starts to the left side, right, then we just draw it out on top. Alright, and the degree is basically just indicated by whatever your expression is. It can be plus 30, it can be minus 40, but you see the difference here. If it's plus 30, then this is actually going upwards. If it's a minus, then it goes downwards. But in terms of the sketching waveform, plus generally means that your graph is actually shifted to the right in reference to our 0. Yeah, if it's plus, then to the left side. So I hope you're very clear about these 3 different conditions. Okay.